I have a video that shows the basics of using the graphing calculator. I have a second video that shows how to use the graphing calculator for a quadratic equation. But now I want to make a video that shows how to use the graphing calculator for a quadratic correlation in statistics. To start with, I made this equation and I kept it simple. It's a standard form: a is equal to 1, h is 1, k is 0. I can simplify that equation and get it into general form, and it's also very simple to look at. A is 1, b is -2, c is 1. Here's a table of values that shows some points that I got by plugging into this equation. I'm going to enter some of those points into the graphing calculator. So the first thing I want to do is clear any old data that's still in the calculator. So I'm doing stat4, which is clear list. And I do second1, second2, which is something we do a lot because what we're saying is the first two columns in my table of values, which is the x column and the y column. I'm clearing that. I hit enter. It's done. So the old data is gone. Now I go into stat mode to enter data. I do stat1, which is edit. And now I see my empty table of values. I'm going to enter just the first 3 points from this table: 0, 1, 1, 0, and -1, 4. And I've got them in. Now I'm going to get the calculator to tell me the ABC of my general form equation and r squared. I do stat. I have to move over to calc, which means I'm using the arrow key here. And then in calc, I'm choosing 5 for quadratic. Then I'm doing second1, second2 again, and I'm hitting enter. And what I just did was tell it to use the x and y coordinates that I had in that table of values to find my ABC and r squared. And I have a of 1, b of -2, c of 1, and r squared of 1. Now we knew that would happen because my a is 1, my b is -2, my c is 1. So the calculator is confirming that we know what we're doing here. The r squared is 1. Why? Because I only entered 3 points. So the correlation is perfect. Therefore, the square root of r squared is the square root of 1. R is also equal to 1. Now what we're going to do is we're going to do it over again with the table of values entered into the graphing calculator. But this time I'm not using an equation. I'm using some data which forms a nice parabola and is quite good, but is deliberately made to be a little bit imperfect because in statistics you're working with experimental data. Data is not perfect, or it really always should not be perfect. So what I did was I just changed my points a little bit. Where I had the point 1, 6, I changed the 6 to 6.1. So these decimals that you see are me moving my points just a little bit. What I predict will happen is that I'm going to get an a, b, c, and r squared. My r squared is going to be quite high. My r, therefore, is going to be quite high because I only changed these points a little bit. So it should be close to a perfect correlation. Let's try entering this into the graphing calculator now. First thing we do, of course, is clear the old data. So I have to do stat4 for clear list. Second1, second2, enter. Done. I cleared the old data. Now, stat. I want to enter data, so I'm going to 1 for edit. And I'm going to enter the x and y's from this table of values on the right. So the x's are 0, 1, 2, 3, 4, 5, 6. And the y's, 1 followed by 6.1, 8.9, then 10, 9.1, 5.9, and 0.9. There, my data is entered. So now it's time to do stat. I need calc, so I'm using my right arrow button to get to calc. I'm choosing 5 for quadratic, and I'm saying second 1, comma, second 2 again, yet again, and hitting enter. And here we go. My A is negative 1.0059, but the rounding will turn it into negative 1.0060. My B, 6.0179. My C, 1.0095. My R squared is equal to 0.9996. My R, therefore, is equal to the square root of that. Which is 0.99, well, it rounds to 1, so I'm not going to round it too high. I'm going to put 0.9998. So what we predicted would happen actually did happen here. We're very close to a perfect correlation because I changed my data just a tiny little bit from the perfect data that an equation would give me. Our equation, therefore, is going to be in general form, and it's hard to fit this, negative 1.0060 x squared plus 6.0179x plus 1.0095. We go to 4 decimal places in order to preserve some exactness, because using quadratic equation for a quadratic correlation is such an inexact science that we try to keep as much exactness as is feasible, or at least convenient. So what we have shown is that, yes, we can use the graphing calculator for quadratic equations, but we can also use the graphing calculator to enter data from a table of values to look for a quadratic correlation. That is today's Daily Dose of Math. Please like, subscribe, and share.